Hey guys, all right. We're going to start off talking about a little stuff that we did yesterday with the irrational expressions, um, and basically just that whenever you see multiplying, right? See how these two things are multiplying here. Whenever there's multiplication on the top or the bottom, and you have the same term like x plus 3, you can cancel those away. So, in this, just to simplify this, these could cancel. Now, notice I don't have the parentheses on the bottom, but I could add them. Right, so you can imagine like the bottom times 1. Point is, it is multiplying on the bottom. So that and that cancel, and it just simplifies to x plus 2. But don't forget, what could x not be? Well, look back at your original here. You have to look back at the original. If you plugged in a -3, x would not work. Or, the function would have no output. You can't divide by 0. So say the answer is x plus 2, but x cannot be -3. And so that means you can't plug in a -3 because then you'll divide by 0. So the question is, what will make the original divide by 0? That's what x cannot be. So, and actually, let's do that in the first one, this next example here. You cannot plug in a -3, so I can already say x cannot be -3. And then I can actually go ahead and simplify the problem. This was a counterexample I wanted to do and show you what not to do. Okay, so up here, they're multiplying, we can take them out. But down here, you cannot cancel away this x plus 3. You cannot do it. Okay? And so, I don't even know if we can. Let's see, can I factor the top? So this is about what we're going to get to the next example, but can I factor x squared plus x plus 3? So it'd be, no, so I can't. So this one actually is simplified as I can get. I mean, I could not do anything. So the answer, if I were to simplify, would just be the same. Okay, you cannot cancel these x's or these 3's away because they are adding or subtracting. You cannot cancel away. All right, so what this is all leading to? Well, sort of. I guess the half width. What this is leading to, right? And what that means is the half and stuff. So on the top, that you also see on the bottom that we could cancel away. Let's see, x plus 3. See this right here? That makes a 1 basically. So I can cancel that out. And that's my answer. What's left over? Real quick, x cannot be -3. Cannot be -3. And it cannot be +3. Because plugging in -3 here would make the graph. You divide by 0. Or if you plug a 3 in here, you're dividing by 0. So we have to make sure we lift those restrictions. But those canceled away, and our final answer is just x plus 3 over x minus 3. And that was it. Yeah, so basically that's what we're doing up here, but you're adding in this first process of factoring everything. This is very, very common in pre-calculus and calculus. So that was 376A. So you need to go do 376B, C, and D. And we're going to do another example here. Up with the process. Here we go. So we're going to do 378. 378 A. Okay, so it says simplify expressions below. So again, I'm just going to copy down the problem here. X squared minus 8x plus 16 all over 3x squared minus 10x minus 8. Okay, now they already gave me the domain restrictions of x cannot be -2/3 or 4. Hopefully that works out. We'll see. On the top, so I got to factor these now. The top, that's going to be, so two numbers multiplied be 16, add to be -8. That'd be -4, -4. So x minus 4 and x minus 4. All right. And again, if you want to double check that, that's x times x squared. -4x is -8x. -4 times -4 is 16. On the bottom, though, I can't use that simple trick of multiply to this number, add to this number, because there's a 3 here. We did a lot of this last week. So I am going to do the box and diamond for this one here. So let me get that set up. Let's see, so this will be a 3x squared here. This will be -8. Multiply these two to go here. That would be -24x squared. The -10x goes down here. There we go. So two numbers that multiply to be the top, add to be the bottom. Looks like multiply to the top. That's be 6 and 4. -6. Let's try -6, -4. No, those multiply be positive. What about 12 and 2? negative 12, positive 2. Yep, that's it. So negative 12x and 2x. They multiply to be negative 24 x squared, and they add to be negative 10x. So I'm going to fill those in over here. And now let's factor things out that are in common. So I got, this would be negative 4 here. This would be x. This way would be a 2. And that would be a 3x. So this simplified to be 3x plus 2 and x minus 4. I would recommend going back and checking that. Foil it out, make sure everything's fine. Alright, now that I've done all that work just to see this expression right here. Does anything cancel out? X minus 4 and x minus 4. See how I'm multiplying? So they go away. And so our final answer is just x minus 4 divided by 3x plus 2. And now they correctly gave us earlier the x cannot be 4. Yep. See right here, that's right there. 4. You can't plug a 4 in, otherwise you're dividing by 0. And you can't be negative 2/3 because that would make this go to 0. So negative 2/3. Great.